A boat travels from A to B and then from B to C. The displacement from A to B is minus 28i plus 20j. Displacement from B to C is 30i plus 15j. So let's just lift out the key information and write it as a column vector, as that's how I prefer to work. Minus 28 and 80, and B to C is equal to 130 and 15. You don't have to work with column vectors, but I usually find that easier. So the total distance, find the total distance. So the distance is the magnitude, of, so that's going to be the magnitude of AB plus the magnitude of BC. It's the distance travelled, not the displacement from A to C. So the magnitude of the vector AB is equal to negative 28 squared plus 80 squared, square rooted using Pythagoras, assuming I and j are unit vectors. So we assumed, which is the convention, I and j are perpendicular unit vectors. They are at right angles to each other. So we form a right angle triangle then here from A to B, and we're going to have a right angle triangle. Okay, so negative 28 squared, well, negative times a negative is positive. 28 squared, well, that's 30 minus 2 squared. 30 squared is 900, minus 2 lots of 30 times 2, which is 120, so that's 780, plus 4 is 784, plus 6400. Okay, so that gives us a total of the square root of 67184. That really is probably a calculator kind of activity, but it's going to, well, we don't need to worry about that because we want the total. We will need it in a minute, but let's do the magnitude of B to C, the length from B to C. So that's going to be 130 squared plus 15 squared, square rooted. So 130 squared, 13 squared is 169, and then we get 0 times 0, plus 225. So it's the square root of 17125. So distance travelled is those two added up, root 7184 plus root 17125. Tapping it in the calculator is going to give us it's going to be around 130-ish probably. Yeah, well, it's going to be 130 because the 15 doesn't make much difference at that level. So 130 plus probably something slightly, well, it is under 100, so perhaps 90, so 220-ish. Tap it in the calculator to see what you get. I get it to come out to be 216 metres to the nearest metre. That's part A. Part B. Find the angle the vector AC makes with the unit vector I. So to do that, we need the vector AC. So A to C is equal to A to B plus B to C. AB was minus 2880, negative 2880, plus 130 and 15, if I've remembered correctly. Let's just check that. Yes, I have. So when we add those up, we get 102 and 95. Now, we're asked for the find the angle the vector AC makes, yeah, the angle the vector AC makes with the unit vector I. So we get, there's I, so we're going to go 102 across and 95 up. Notice please that the vectors go from nose to tail, yeah, to create the direction. It's this one plus this one, sorry, this one plus this one. All right, and there's our resultant. And we're asked for that angle in the question. So tan theta is equal to the opposite, which is 95, over the adjacent, which is 102. So theta equals arc tan of 95 over 102, something slightly less than 1, so the angle is going to be slightly less than 45 degrees. Tap it in the calculator, 43.0 degrees to the nearest tenth of a degree.